All right, here we're on part D, graphing exponential functions. So you'll want your graphing calculator, or you can use Desmos if you'd like. So looking at my graphing calculator, I'm going to type my function into y1. So my base here is a fraction, so I put it in parentheses, 1/3 raised to the x power. Let's look at the graph. Okay, remember here, this graph on the calculator looks like it stops, but it doesn't really. The calculator just does a bad job of showing you that this is getting closer and closer and closer to 0. Okay, so this line would be continuing, and Desmos does a little bit nicer job of showing you the calculator, or sorry, showing you the graph than the calculator. I'm going to go to my table, and I want to figure out the y values, starting with -2. So I'll plug those guys into my table here. So I have 9, 3, 1, 3, 3, 3, 3, 0.1111, 0.037. And then I'm going to plot each of those points. Okay, so you guys can plot them here. So -2, up 9, -1, up 3, 0, 1, 1.333. I'm getting closer and closer and closer to 0. Like something like this. So notice I'm drawing arrows at the end, showing that that graph would be continuing. Okay. Now that we've graphed it, let's look at some key features. So first I want to decide, is this a growth or a decay model? I can decide by looking at the base of my function. The base here is less than 1, so that tells me right away this is a decay model, and my graph is decreasing as I move left to right. Then I want to find the rate, meaning the decay rate. Now to do that, we set up a little equation here. So I'm just going to take our base, 1/3 of the x. I'm going to write that instead of 1/3, I want it to be written as 1 minus some number to the x. So I need whatever I fill in here to end up being equal to 1/3. Okay. Now I'm doing minus because it's a decay. So instead of the whole number 1, I'm going to write it as a fraction with a base of 3. Sorry, with a denominator of 3. So I know if I have 1/1, to get it to be a denominator of 3, I can multiply by 3 on the top and the bottom. 3/3 minus something to the x. Because in order to subtract fractions, I would need the same denominator. Now, if I want 3/3 minus something to equal 1/3, it's going to be minus 2/3. This is my rate right here, but I want to multiply by 100 to get the percent. When I do that, it's about 66.7% decay. My horizontal asymptote, I can see visually from my graph. This graph is getting closer and closer and closer to 0, and I can confirm that with my table. So my asymptote is going to be at y equals 0. Domain is all x values from left to right. So even though it looks like it's going straight up, it's actually going a little bit to the left here as well. So I would eventually cover all values on the left, and it's definitely going all the way to the right. So typically our domain for exponentials is -infinity to infinity. It's our range that's a little more limited. I don't see anything in the graph down here, so I see my range is not going to start until that asymptote at 0, and then the y values will go up forever. So up to infinity. My x-intercept. So if I have an asymptote at 0, it's not going to touch 0. It's getting super, super, super close. So I actually do not have any x-intercept. My y-intercept I can see on the graph, and I can see it on the table. So x is 0, y is 1. End behavior. So as x goes to infinity, that means you're looking at positive x values forever, so towards the right side. The right side of the graph is getting closer to 0, the actual graph, the y values. As x goes to negative infinity, that means look on the left side, find the end. The end of the left side is going up to positive infinity. And lastly, our average rate of change. This is another way of saying slope. We have to use our slope formula here. So our slope formula, y2 minus y1 over x2 minus x1. Now we need some coordinate points. We're telling you we're looking for the slope from x equals -2 to x equals 1. So these are both of our x values. We need to go back and figure out the y values. So I like to kind of sketch it out. So x of -2 and y of something, x of 1, y of something. Now I can go back to my table to figure out those missing values. So when it's x is -2, y is 9. When x is 1, y is 0.333. So I can plug those in here. And then I'm just plugging those into my formula and calculating the slope. So y2 be down here, 0.3333 minus y1, 9, over x2, 1, minus -2. Simplifying, I have -8.67 on top. 1 minus -2 becomes 1 plus 2 is 3. When I do this division, I get -2.89. Now I'm done.